My dear students, welcome back to our channel. Students, in this video I am explaining JNTU Hyderabad MBA first semester. Subject Research Methodology and Statistical Analysis. Important short and long questions and answers. Let's start quick revision. Third unit. First important short question is: what is univariate and bivariate and multivariate data? Univariate data refers to data that involves only one variable. For example, the heights of students in a class. Bivariate data involves two variables and explores the relationship between them. For example, the height and weight of students in a class. Multivariate data includes more than two variables. For example, the height, weight, and age of students in a class. In summary, univariate one variable, height. Bivariate two variables, height and weight. Multivariate more than two variables, height, weight, age. Next important short question is: what is data classification? Data classification is the process of organizing data into categories or groups based on certain characteristics or criteria. It helps in understanding and analyzing the data better. For example, classifying animals into categories like mammals, reptiles, and birds based on their features, such as having fur or feathers. In summary, data classification helps group data into meaningful categories, making it easier to analyze. For example, classifying emails into spam or not spam helps to manage them better. Next important short question is: define tabulation. Tabulation is the process of organizing data into a table or chart to make it easier to understand and analyze. It arranges information in rows and columns, showing the relationship between different data points. For example, if you collect the number of apples and oranges sold each day, you can create a table with days as rows and fruits as columns, showing the quantities sold. In summary, tabulation helps to present data in a clear, organized way, making it easier to compare and interpret. It's like turning messy information into a neat table for better understanding. Next important short question is: what is a test of two means? A test of two means is a statistical method used to compare the average values, means, of two groups to see if they are significantly different from each other. For example, you might compare the average test scores of two classes to see if one class performed better than the other. There are two types of tests. 1. Independent t-test for two unrelated groups. 2. Paired t-test for two related groups, like before and after measurements. In summary, this test helps determine if any observed difference between two group averages is meaningful or due to random chance. Next important short question is: paired t-test. A paired t-test is used to compare the means of two related groups. It's helpful when you measure the same group of people or items before and after an event, treatment, or condition. Example: suppose you measure the weight of 10 people before and after a 3-month fitness program. You would use a paired t-test to see if there's a significant difference in their average weight before and after the program. In summary, the paired t-test helps determine if there is a significant change in the paired data, such as pre-test and post-test scores. Next important short question is: what is a null hypothesis? A null hypothesis is a statement that assumes there is no effect or no difference in a study or experiment. It suggests that any observed change is due to chance rather than a real effect. Example: if you are testing whether a new drug improves patient recovery, the null hypothesis would be the new drug has no effect on patient recovery. In summary, the null hypothesis represents the idea that there is no significant difference or relationship. It is tested to see if evidence exists to reject it in favor of an alternative hypothesis. First important long question is: one-dimensional, two-dimensional and three-dimensional diagrams and graphs. One-dimensional, two-dimensional, and three-dimensional diagrams and graphs refer to how data is visually represented using different dimensions or axes. Here's an explanation with examples. 1. One-dimensional diagrams and graphs. A one-dimensional graph represents data along a single axis, usually the x-axis. It focuses on one variable and shows its values or distribution. Example: a bar chart showing the number of apples sold each month. The months are listed on the x-axis, and the number of apples sold is shown on the y-axis. In summary, a one-dimensional graph displays data on a single axis, making it easy to compare values of one variable at a time. 2. Two-dimensional diagrams and graphs. A two-dimensional graph involves two axes, the x-axis, horizontal, and the y-axis, vertical. It shows the relationship between two variables and helps in understanding how one variable affects another. Example: a scatter plot showing the relationship between height and weight. Height is plotted on the x-axis and weight on the y-axis, with each point representing a person's data. Another example is a line graph showing how temperature changes over the days of a week. The days are on the x-axis and temperature readings are on the y-axis. In summary, two-dimensional graphs allow us to see relationships between two variables, helping to understand trends or patterns. 3. Three-dimensional diagrams and graphs. A three-dimensional graph adds a third axis, usually the z-axis, depth, to represent more complex relationships involving three variables. This allows for the representation of more detailed data. Example: a 3D scatter plot that shows the relationship between height, weight, and age. Each point represents a person's data with values for height, weight, and age. Another example is a 3D surface graph, which might show the topography of a mountain range, where the x and y axes represent horizontal coordinates and the z-axis represents elevation. In summary, three-dimensional graphs provide a visual representation of more complex data involving three variables, giving a fuller picture of relationships and trends. Conclusion. In short, one-dimensional graphs deal with one variable, example, bar charts. Two-dimensional graphs compare two variables, example, scatter plots, line graphs. Three-dimensional graphs represent data with three variables, offering a deeper analysis, example, 3D scatter plots, surface graphs. Next important long question is: explain about measurement of central tendency and dispersion. Measurement of central tendency and dispersion are two important concepts in statistics used to describe and analyze data. Here's an easy explanation with examples. 1. Central tendency. Central tendency refers to the middle or typical value in a data set. It helps to summarize a set of data with a single value that represents the center of the data distribution. The most common measures of central tendency are mean, median, and mode. Mean, average, the sum of all values divided by the number of values. Example: if the ages of 5 students are 10, 12, 14, 16, and 18, the mean age is equal to 14. So, the mean age is 14. Median, the middle value when the data is arranged in order. Example: for the ages 10, 12, 14, 16, and 18, the median is 14 as it is the middle value in the ordered list. Mode, the value that appears most frequently. Example, if the data is 10, 12, 12, 14, and 18, the mode is 12 because it appears most often. 2. Dispersion. Dispersion refers to the spread or variability of data, showing how much the values differ from the central value. The common measures of dispersion are range, variance, and standard deviation. Range, the difference between the highest and lowest values. Example, if the data set is 10, 12, 14, 16, and 18, the range is 8, so the range is 8. Variance, the average of the squared differences from the mean. It gives a sense of how spread out the data is. Example, to calculate the variance, you subtract the mean from each data point, square the result, then average those squared differences. Standard deviation, the square root of the variance. It also tells how spread out the data is, but in the same units as the original data. Conclusion. Conclusion. Central tendency measures where the center of the data lies, mean, median, mode. Dispersion measures how spread out the data is, range, variance, standard deviation. Together, these concepts help to better understand data by giving us both an idea of where the data tends to fall and how spread out it is. Next important long question is: what is t-distribution, properties and applications? What is t-distribution? The t-distribution is a probability distribution used when you are working with a small sample size, usually less than 30, and the population standard deviation is unknown. It is similar to the normal distribution but has heavier tails, meaning it accounts for more uncertainty and variability in small samples. For example, if you want to estimate the average height of students in a class, but you only have a small sample and don't know the population standard deviation, the t-distribution helps in making more accurate inferences about the population mean. Properties of t-distribution. 1. Shape. The t-distribution is bell-shaped, just like the normal distribution, but it has thicker tails. This means that there is a higher probability of extreme values, outliers, compared to the normal distribution. 2. Symmetry. It is symmetric around 0, meaning the distribution looks the same on both sides. 3. Mean. The mean of the t-distribution is 0. 4. Variance. The variance of the t-distribution is greater than 1 and depends on the sample size. As the sample size increases, the t-distribution approaches a normal distribution. 5. Degrees of freedom, df. The shape of the t-distribution depends on the degrees of freedom, df, which is related to the sample size, df is equal to n1, where n is the sample size. The smaller the sample size, the more spread out the distribution is. 6. As sample size increases, the t-distribution becomes closer to the normal distribution. Applications of t-distribution. 1. Estimating population mean. The t-distribution is commonly used to estimate the population mean when the sample size is small and the population standard deviation is unknown. For instance, you can use the t-distribution to find confidence intervals or perform hypothesis testing on the sample mean. Example, if you measure the heights of 15 students and want to estimate the average height of all students, you'd use the t-distribution because the sample size is small. 2. Hypothesis testing. In hypothesis testing, example, t-tests, the t-distribution helps determine whether there is a significant difference between sample means, especially when working with small samples. Conclusion. The t-distribution is crucial for analyzing small sample data and making inferences about a population. It is bell-shaped but has thicker tails to account for the increased variability with small samples. The t-distribution is widely used in estimating population parameters and hypothesis testing when the sample size is small and the population standard deviation is unknown. Next important long question is: use the sample data below to test the hypotheses O, P1 is equal to P2 is equal to P3. To test the hypothesis H0, P1 is equal to P2 is equal to P3, we are testing whether three population proportions are equal. Typically, this is done using a chi-square test for homogeneity when you have categorical data. Steps to perform the test. 1. State the hypotheses. Null hypothesis, H0 P1 is equal to P2 is equal to P3, the population proportions are equal. Alternative hypothesis, H1 at least one proportion is different. 2. Set the significance level, usually alpha is equal to 0.05. 3. Collect the data. The sample data should consist of frequencies for each group. For example, if you have counts of outcomes for 3 different groups, it could look something like this. 4. Calculate the expected counts. The expected frequency for each cell is calculated as. For example, the expected frequency for group 1, success, would be E11 is equal to 50 times 90, 150 is equal to 30. 5. Calculate the chi-square statistic. The chi-square statistic is calculated using the formula, where OH is the observed frequency and age is the expected frequency. 6. Find the critical value. For a given significance level, alpha, and degrees of freedom, you find the critical value from the chi-square distribution table. The degrees of freedom are calculated as. In our example, df is equal to 2. 7. Compare the test statistic to the critical value. If chi2 is greater than the critical value, reject the null hypothesis. If chi2 is less than or equal to the critical value, fail to reject the null hypothesis. Example. Let's say the observed values and expected values are calculated, and the chi-square statistic is chi2 is equal to 5.4. If the critical value for df is equal to df is equal to 2 at alpha is equal to 0.05 is 5.99, then since 5.4 5.99, we fail to reject the null hypothesis, meaning there's no significant difference between the proportions of the 3 groups. Conclusion. By using the chi-square test, you can determine whether the 3 proportions are statistically different. If the chi-square statistic is higher than the critical value, reject the null hypothesis, otherwise, you cannot reject it. Next important long question is: 10 students are selected at random from a school and their heights are found to be, in inches 50, 52, 52, 53, 55, 56, 57, 58, 58 and 59. In the light of these data, discuss the suggestion that the mean height of the students at the schools is 54 inches. You may use 5% level of significance for applying t-test. To evaluate the suggestion that the mean height of students at the school is 54 inches, we can perform a one-sample t-test at a 5% significance level. Step 1. State the hypotheses. Null hypothesis, H. The mean height of students is 54 inches. Mu is equal to 54. Alternative hypothesis, H. The mean height of students is not 54 inches. Mu is not equal to 54. Step 2. Calculate the sample mean and sample standard deviation. Given heights in inches 50, 52, 52, 53, 55, 56, 57, 58, 58, 59. Sample mean, x, 55 inches. Sample standard deviation, S, calculating the squared differences from the mean. Sum of squared differences equals 86. Sample variance is 9.5556. Sample standard deviation is 3.091. Step 3. Compute the t-statistic. T is equal to 1.022. Step 4. Determine the degrees of freedom and critical t-value. Degrees of freedom, df equals 9. For a two-tailed test at alpha is equal to 0.05 and df is equal to 9, the critical t-value, t.025, 9, is approximately plus or minus 2.262. Step 5. Make a decision. Since the calculated t-statistic, 1.022, is less than the critical value, plus or minus 2.262, we fail to reject the null hypothesis. Conclusion. At the 5% significance level, there is insufficient evidence to conclude that the mean height of students at the school differs from 54 inches. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject quick revision. Important questions. Previous question papers. And syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.